right, in this video today we're going to be reviewing for your quiz coming up on Wednesday over chapter 1.1 to 1.2. So I'm going to do one problem of each type and then you will complete the worksheet on your own, and I'll post the key so you can check your answers. If you have any questions on anything on this review, please email me and I will get back to you. So the first thing we're going to go over is how to read a graph for key functions. So the first key function would be the domain and then the range. So looking for the domain, we're looking at the x values and we're going from left to right on the graph. So I go all the way to the end of the graph on the left side, and it's right here. And then the x value there is 2.5. Negative 2.5. And then all the way to the right, the x value there is 3. Now let's do range. Range is all the y values, so you're looking at the y-axis to find your interval numbers. You start at the very bottom of the graph, go over, that is at negative 10. Then the top of the graph is up here at 16. X-intercepts is where the graph crosses the x-axis, so that's at the point 0, 0. And then just before 3, so let's call that 2.9. It's right there, just before 3. Okay, y-intercepts, there's only one, it's at 0, 0. That's where it's crossing the y-axis. Negative interval is anything below the x-axis. So that would just be this piece right here. And we're looking at the x values. So 2.9 to ends at 3 here. So 2.9 to 3. And that is a closed circle there at 3, so it gets the bracket. Positive is anything above. So from here to here. So starting at negative 2.5. Close there, so I got the bracket. Negative 2.5 to that 2.9. All right, increasing is where the graph is going up. So from negative 2.5 to 2. Always use parentheses for increasing, decreasing. And then from 0 to 2. Well, that's negative 2 there. 0 to positive 2. Decreasing where it's going down, so from negative 2 to 0. And then from 2 to 3. Okay, rate of change. Rate of change, these are your x values. So this is my x1 and my x2. So my first x is at negative 1. So negative 1 is right here. And I'm going to see what the y value is at negative 1. Hits the graph right there. And that's at negative 8. So, or positive 8, sorry. So that's negative 1, 8 would be my first ordered pair. Then the next one is at 2, which is right here at 16. So 2, 16, and then I'll plug it into my slope formula. So that's y minus y over x minus x. So that's 8/3 for my rate of change. right, you'll try the next one on your own. Let's go to the next page, number 19. It says a jet descends from 20,000 feet at a rate of 1,500 feet per minute. Give the domain and range in set builder notation. So let's draw a picture to see what's happening here. So I have a jet at 20,000 feet high. 20,000 feet up in the air. And then it's descending, it's going down at a rate of 1,500 feet per minute. So over here, my y values would be the height, and my x values would be the time it takes to descend. So each minute it's going down 1,500 feet. So I need to figure out how many minutes is it going to take to complete the descent. And then, so I would do 20,000 divided by 1,500, and that works out to 13.3 repeating. We'll just call it 13.3 for our purposes. So it takes 13.3 minutes to complete. So the domain, my x value would be the time, and that would be from 0 to 13.3. The starting time is 0, the ending time is at 13.3. Then we'll put it into set builder notation. So that's from 0 to 13.3. Reading the graph left to right, we start at 0 and we end at 13.3. So that would be the interval notation. So I put it over here in set builder notation because that was the direction there. And then the range would be from bottom to top, so from 0 to 20,000. And that was how you would find the domain and range there. All right, 22. Over what interval is the graph y equals negative absolute value of x minus 4 increasing? Well, first I have to graph this. So I know that this is going to be an absolute value. So the parent function of absolute value is f of x equals the square root of x. And from the parent function, I see that it's a reflection because of this negative out in front. And I also see that it's going to move to the right 4. The number inside moves it either left or right, and because it's subtraction, that moves it to the right. So now I can graph. So I'm going to go over to the right 4. 1, 2, 3, 4. And I know it's going to open down because of the reflection. So now I have it graphed, but I want to know what interval is it increasing. So increasing means it's going up. So the graph is going up here. And I'm looking at x values. This would be negative infinity. Arrow means it keeps going. Negative infinity to 4 here. So it is increasing from negative infinity to 4. All right, you're going to try 23. 24. So the function f of x is represented by this table. So f of x would have these x values that output these y values. What happens when you change the function to 2 times the function? So that would give me, that 2 would give me a stretch, a vertical stretch by 2. Now think back when we were graphing those quadratics, we were talking about stretch and compression of quadratics. We said you had to multiply the y values by whatever that stretch or compression was. So that would be our 2 there. So I'm going to multiply all of these y values by 2, but these x's stay the same. So my new table, x's would stay the same. And then 9 times 2 is 18, 2 times 12 is 24, and so on. Fill in the chart. Okay, moved on to 26. Write an equation for the following transformation of y equals x, linear function there, a vertical compression by a factor of 1/2. So compression and stretches, we know it's a compression or a stretch by that number that's in front. Just like what we saw up here, that was a stretch of 2. That function is being multiplied by 2. We're going to do the same thing down here. So my parent function is y equals x, and then it's compressing by a factor of 1/2, so that half just goes out in front of the x. So the answer is y equals 1/2 x. Moving on to 29. It says let g of x be the reflection of f of x equals 2x plus 4 in the x-axis. What is the function rule for g? Think about what a reflection does. Reflection flips it or reflects it across the x-axis, and we know to do this because there's that negative out in front of the function. So in order to make a reflection of this function, f of x here, we need to make it negative. To reflect it, it needs to become negative. So I'm going to take the function and make it negative. So g of x equals negative 2x plus 4. And then I would also have to distribute this negative. So g of x equals negative 2x minus 4. It's very important that you remember to distribute the negative or you will not get the correct answer. Distribute the negative. Okay, let's go down to 32. Function is f of x equals x squared. That's a quadratic function. And then we want to know what happens if we're going to translate this parent function to the left 4 and down 6. What would be the new equation? So we're going to start with g of x equals, my parent function is x squared. I know it's going to go to the left 4, so we're going to add 4 inside. And then it's going to go down 6, so minus 6 goes outside the parentheses. Okay, let's go to the last page here. Down to 36. Write the equation that represents the graph below. So we're given the graph, we need to write the equation. So I know that this is an absolute value because it has that V shape, absolute value function. The parent function is f of x equals absolute value of x for absolute value. And then I see that it's moving to the left 1, and then it's moving up 4. I also see that it's opening down, which means it's a reflection. And then I'm going to check the slope here. 1 over 1, 1 over 1, 1 over 1. So there's no stretch or compression, so I don't have to worry about that. Then I'll put it all together. My new function g of x equals, the reflection is the negative, the absolute value of x, left would be plus 1 inside, and then up would be plus 4 outside. All right, go ahead and finish up this worksheet on your own and then check your answers when you're finished. Email me with any questions.